So hello and welcome to another Boston Labs blog with me, David Power. Today I'd like to speak to you about a new technology which allows users to run x86 binaries on top of an ARM server, such as the Boston Viridis server. The software we're using comes from Eltechs and is called ExaGear. This technology intercepts x86 applications and converts them in runtime to ARM-compatible code using binary translation technology. This entire process is very straightforward and completely transparent to the end user, as I shall demonstrate shortly. This is a huge leap forward for the ARM server ecosystem. One of the most common barriers to ARM adoption in the data center that I hear from customers is that some old legacy applications just aren't ported to ARM, or people do not have access to the source code to recompile for the ARM architecture. In some instances, the effort to port to ARM has been too large a task for some small teams to take on. This technology addresses all of those concerns and just allows users to run x86 binaries on an ARM server. So let's log into our ARM system to run a quick demonstration of this. Okay, so we've just logged into a Ubuntu 13.04 OS. This is running the ARM v7 architecture. If we take a quick look in proc CPU info, we can see that we have 4 ARM v7 based cores exposed to the operating system. So this is a Cortex A9 based system. When we check the output of uname -a, we can see that our kernel and system are reporting it's an ARM based architecture. And a quick check on the binaries on the system, we can see that they're all ARM architecture binaries. So with that said, let's take a look at the ExaGear software. So the packages are already installed on our system. So there's 2 packages. The first one is the actual binary translation system itself. And then the second package there is a minimal guest system, which is used to actually run the ExaGear environment, very much like a chroot environment, if people are familiar with that. So with that said, we take a look at the output from ExaGear-ls, which will show us all of our guest images that are available for us. And then to actually start up the environment, we just run ExaGear itself. So this is starting up in the background. All it's doing here is really running all of the init scripts for services, startups, and anything else that you need to do on OS initiation. Now that we're in the environment, we can rerun some of the commands that we just ran a short while ago. So again, we'll take a look at uname -a. As we can see in our earlier output, the ARM architecture is reported when we run it locally or natively in our ARM system. And now under the ExaGear environment, we can see that it's reporting that it believes the system is an i686 386 system. Again, when we run the output of file, we can see that our executables that we're using are all built for the Intel x86 based instruction set. This corresponds, of course, to the ARM output that we had a short while ago. So now that we're in this ExaGear x86 environment on top of an ARM system, we can go ahead and run any x86 based binaries that we actually want to in a very trivial and transparent manner. You can even go to the standard package manager and add any additional packages that you want to your system. So as we can see here, we're installing the Nginx package. And now when I do a which Nginx, you can see it now installed in user sbin. So I can now run this. And just to verify, we have just run an Nginx based x86 binary on our ARM server just to output the help, and everything worked as we were expecting. when we exit out of the system again, we're back into our ARM server. So again, if I have a quick look at which file, this confirms that our binaries are all ARM-based again. And I can actually take a look at the Nginx binary, as all of the guest operating system is stored inside an opt ExaGear images in here. So that's our root folder for our ExaGear environment, and we should have Nginx in here again. Yes, we do. And again, we can see that this is our Intel-based binary, which we just ran inside in our ExaGear environment. So there you have it. That was a demonstration on running x86-based binaries on top of an ARM server. This is a huge leap forward for the whole ARM ecosystem, especially with regards to the migration to ARM in the data center. I'd encourage everyone to keep an eye on our blog, lowpowerservers.com, as very shortly we will be posting benchmark results on the ExaGear environment, on what the overheads are for actually running applications within this environment.